This is your online module on data visualizations. At the end of this module, you will be able to identify different visual representations for single numerical or categorical variables, identify different visual representations for two or more variables. There are specific plots you can use depending on how many variables you have and which data types they are. So here is a summary of the ones that you can use for one numerical variable, for one categorical variable, two numerical variables, two categorical variables, or combinations of them. Here's just for your reference, and we're going to talk a bit about each of them. But keep in mind that this is not an extensive list. There are many more type of graphs that you can generate. This is just a baseline that you need to be aware of. So first of all, let's start with the plots for one numerical variable, which first is the dot plot, which you see is it appears in a horizontal line all the values of a single variable, in this case interest rates, and you can see that the intensity of the dots actually declare that there are more observations in the darker spots than the lighter spots. The red triangle, of course, indicates the mean location or the center location. The modified version of the dot plot is the stacked version, in which you can actually see that observations are one on top of the other. And this gives a lot of detail because you can see it as each level of the values, right? So this is 5, this is 6, 7, 8, 9, and 10. While this mimics somehow a histogram, the histogram groups observations. So we're going to be talking about that now. So you can see here that a histogram for the same type of data actually has bins that you create, and for that bin you define what is the margin for each the width of each bin, and then you count all the observations that fall in that bin. From there, then you can say a lot about the distribution of a variable, of course, and this is the traditional way to represent a quantitative or a numerical variable. So you can see, for example, that the center is located just below 10%, that is spread from 5 to 30%, that most of the observations actually fall in between 5 and 15%. So all of those things you can say. Also, you can identify some skewness if present, like in this case, we have some skewness to the right. On the other hand, we have the plot on the right, the Massachusetts COVID-19 that's by age group. So you do the same thing, right? You have the information about age, and then you check the frequency of those events. In this case, the bins are created based on the age spaces that we consider. But also make sure that you actually like transport these to the other space, because sometimes people can say that this is a category and not necessarily a range of a numerical variable. So in that case, this will become a bar plot instead of a histogram. But that is a traditional way to generate a histogram. You create the bins, or you decide what the bins width are, and then count within that bin how many observations you have. So the bin width is important because if you make your bin width really wide, basically you won't have a lot to say, like for example in this first case, and then it starts giving some extra detail in here, but then it actually gives a lot more detail in the one on the bottom left. And then once you get to the nitty-gritty detail of every two or one values, then you might have too much that it becomes overwhelming or not necessarily that useful. So in between the top right or the bottom left would be a suitable representation depending on your intention. So how much you want to reveal, how much you are comfortable on the aggregating, that is basically a decision that you need to take depending on the variable that you're dealing with. So here is an example histogram for two data series. So here is the household vehicle age distribution for two different years, 2009 in gray and 2017 in bluish. So this is the percent of household vehicles with the particular age age. So you can see that here the observations are actually really like fine or detailed at the year level. So from there, then you can actually create a distribution shape without actually paying attention to the bars themselves. So you can also do that when you perform your analysis. This is still a histogram or a distribution plot, right? So just for your information. So another plot for a numerical variable is a box plot. Now that you are familiar with quartiles and the median, you could create this plot by actually the box is determined by Q1 and Q2. The center of the box is the median. The max and the min of these little tails that are called the whiskers are calculated by particular estimations that I will add here in a minute. And then you can identify, once you have that distribution of that box, which observations actually fall way beyond, which will be basically suspected outliers, and we will be talking about outliers later on. So the value of this is, of course, is because you know that the box actually contains 50% of the data. You can identify like where the main core of your data actually lies, right? So it groups information really well. So from there, if we have two numerical variables, you know that we can use a scatter plot in order to see any potential relationships in between the two. For example, here we have total income on $1,000 and the loan amount that people might get from a lender. And we can see that there is some positive relationship in between that the highest you have your income, the highest amount that you're likely to get from a loaner. So when we switch gears for plots for one categorical variable, make sure that you pay attention to the bottom of the x-axis. In this case, we have a bar plot because these are categories, even though the y-axis is still frequencies, just as in a histogram. So here we have another example. Here is different classes or different groups for school preparation, and then the y-axis is annual income reported. So you can see like how we can see some relationship, right, in terms of this might be considered as a categorical ordinal, if you want, in terms of years of preparation, right? So the highest you have got, then it's most likely that you're gonna get higher annual incomes. So from there, we can also make arrangements for looking at two categorical variables at the same time. In this particular case, on the right, you have a stacked bar plot, which basically says, okay, I have two different categorical variables and I want to see the frequency within. So this is the one for the category rent in terms of home ownership, and then the next categorical variable is it's a joint or individual, and then you can make another split and check for that distribution too. And same thing with the second class and the third class. So you basically explore one category within another category. And then this is a mosaic plot, which basically represents proportions. I'm sorry. So you have the different categories of the original categorical variable, and then you infuse the second categorical variable, but all of these are considered proportions. So basically this is 100% of the rent observations, and then they are split in terms of the proportion of which one belongs to which category, and then same thing with the mortgage and same with own. As well, the size of the bars have a proportion related to the size of their group, you see. So for example, the smallest group is own, which has the narrower bar. the largest group is mortgage, which has the widest bar. So plots for combining variables. This is an intensity map. So as you might remember, like a state is a categorical variable, right? Or county or whatever category that cannot be used as a number. So in this case, we have the categorical variable of location and then a numerical variable of change in population. So which is then categorized as different ranges. So you color code those ranges, and then you can see two different variables at the same time within the locations of the United States. Another way of combining variables, a multidimensional bar plot. For example, here we have again the educational level of a sample and annual income. That relationship, you can still see the upward relationship. But also has an extra categorical dimension in, which is ethnicity, right? So then within each group, it breaks down, and then you can observe each color distribution and see how they differ in between each other. Finally, this is another plot for combining variables. These are overlapped histograms or box plots. So for example, this is change in population, locations with change of population amid the United States. So and the relationship with income, right? So for states that had gains in their population, then the distribution is 1, and the median income is actually higher. And for those that didn't gain, then the median income is actually comparatively lower. And if you want to see the whole distribution of them, then you can create some silhouette histograms to compare each other, right? To see how actually different their medians are or their means, or their skewness, or how many outliers do you have, and things like those. So you surely can add a categorical variable to compare certain numerical characteristics. So this is all for this online module. Is your time to practice. This is a reminder of the learning objectives. Check your understanding by taking the quiz.